protons, neutrons, and electrons. So for this one, first you need to remember that the number of protons is equal to the atomic number. The electrons is equal to the number of protons only if the atom is neutral. Usually, unless you're given additional information, you need to assume that the atom is neutral. And that in order to calculate the neutrons, it's simply the atomic mass minus the atomic number. You already know that atomic mass is composed of protons plus neutrons. Atomic number is just protons, so this number minus this one will give you the a number of neutrons. Or this is an easy way to just learn that is the big number minus the small number. So it's another way, but it's better if you learn atomic mass minus the atomic number. For this one, you're gonna be using the periodic table, and the first thing that you need to know is like locate the element in the periodic table, identify which one is the atomic number. Usually the atomic number is in the upper part of the square. Then you have the symbol, the name, and then you have the atomic mass. Some periodic tables don't have it rounded up. So in this case, 15.9, if you're gonna use a number, you need to round it off, up or down. If it is more than, if it is 0.5, more than 0.5, to the next number up. If it is less than 0.5, so to the next number down. So in this case, we have 15.9. So for calculations, we're gonna use 16. Remember that key important factor when you're calculating, because if you don't do this, you're gonna end up with decimal numbers, and it doesn't make any sense to have 0.7 protons or 0.3 neutrons. So that's why we need to round this off. Remember that this number only comes from the average of the atomic masses, and that's why we end up with a decimal number. So once we have this one, we just need to remember that in some cases you're going to be given this kind of a isotope notation. This X represents the symbol of the element. A is the atomic number or mass number or nucleon number. Z is the proton number or atomic number, and C is the charge. So if it is a neutral atom, there will be nothing here. But if it is an ion, remember that an ion is something with charge. You're gonna see either a positive or a negative number right here, and that's what we're gonna discuss now. What does it mean, the ion? So this is quick information about ions. So a positive ion is when it has more protons than electrons. It is not that you added protons, because when you add protons, you change the element. This is because you have you are losing or gaining electrons. In this case, positive, you have more protons than electrons. The atom has lost electrons, and the charge tells you how many electrons have been lost. +1, +2, or +3 are the most common. So +1, it has lost 1 electron, +2 that it has lost 2 electrons, +3 that it has lost 3 electrons. A negative ion is when it has more electrons than protons. The atom has gained electrons. So here we can have that the charge as well, the most common are plus -1, -2, or -3. Another name that we have, the positive ions are also called cations, and the negative ions are also called anions. Those are two terms that you should be familiar with. Cation, positive ions, anions, negative ions. So for the following exercise, we're gonna just use the periodic table. This is the typical periodic table that you're gonna have, and they give you a key right here. It says the atomic number, atomic symbol, name, and the relative mass. In this case, it's already rounded off, so you can see that it has a whole number. So when this is the case, you don't have to worry about rounding off the number. So you just use it as it is right here. This is very important because from now on we're gonna continue using the periodic table a lot. So let's do some calculations right here. For example, you need to complete this table as the example boron. You can find, for example, you just go boron in the periodic table. We have it right here. So we know that it has an atomic mass of 11 and an atomic number of 5. And then we can just see here the mass number 11, the atomic number 5. and the number of protons is 5 because it has 5 as atomic number. Neutrons is 11 minus 5, so you have 6. And electrons is 5, is the same number of protons, because we assume it is neutral because nothing else has been given. In the case of sodium, so we need to just come here and find sodium. This is sodium, the symbol is Na, atomic mass 23 and atomic number 11. So here we have sodium, so the symbol, we already know that it's Na. Notice that when you just have two letters in the symbol, if the first one is uppercase and the second one is lowercase, this is just one element. If you have two uppercase together, those are two different elements. So this is sodium. Here they're giving you that the mass number is 24, and here in the periodic table we see that it's 23. So this is not a mistake. This is because this can be an isotope of the element. So you have to be careful when you just do those calculations, because sometimes they give you the mass of the isotope, not the mass that you have in the periodic table. And students tend to make that mistake very much. So in this case, the number of protons stays the same, 11, but the number of neutrons is not 22. The number of neutrons is 23, 24 minus 11, which is 13, because here this is an isotope. And the number of electrons, since nothing else is given, we're going to assume that the number of electrons is just the same number of protons, 11. For these elements right here, for example 39, you can see that the number of electrons, and since nothing else is given and we assume that this is neutral, so you just find which is element 39 in the periodic table. You can see that the element 39 in the periodic table is yttrium. So the mass number is 89 and the atomic number is 39. So here you can complete here with 39 and 39, and then the difference here is 89 minus 39, that's going to be 50 right here. So that's what we use in order to complete this table. Here, the most important part is that notice the mass number, because you may lose one mark here if you use the mass given in the periodic table. If you use, for example, 23, because in this case, they are giving you the mass of an isotope. So sometimes they give you something like this. They give you the element, they give you the charge. In this case, they give you the mass number, and they give you this one. And then they ask you to calculate the number of protons, neutrons, and everything. So neutrons in this case, as you know, is mass number minus atomic number. So 141 minus 56. So that's going to be 85 neutrons. And here the key is, we would say that the number of electrons is 56 because you have 56 protons. However, we can see that it has a charge of +2, so it means that it has lost 2 electrons. So that means that if you originally had 56 minus the 2 electrons that it has lost, then now you have 54 electrons, because this is a cation. It has lost 2 electrons. So this is important when you just do this calculation. In this case, let's do the calculation right here. The atomic mass, based on the information that we have from this notation, the isotope symbol, we have the atomic mass is 16. The number of protons is 8. The number of neutrons is 16 minus 8, so that's equal 8. And then electrons, originally you have 8. But in this case, 2 negative means that it has gained 2 electrons. So you need to add 2 electrons. So that means that now you have a total of 10 electrons. This is a cation because it has lost electrons. This is an anion because it has gained electrons.